Okay, I'm back, and so now we want to talk about what is it that causes the storms and the winds on Jupiter and Saturn. So weather on Earth, we talked about that last lecture, and we said that energy from the sun heats up the atmosphere, and then that causes pressure, temperature, and humidity differences, which drive weather systems. And then the wind speeds, though, are limited by friction with the Earth's surface. So as the winds blow across the solid surface of the Earth, there's some friction, and then that tends to slow down the wind systems. However, let's look at on Jupiter and Saturn, a gas hydrogen, as the gas hydrogen changes into a liquid and metallic hydrogen, it gives off heat, which fuels the storms. So the best way to understand this is to pretend that you've got some solid ice, okay, and then it's going to, let's say that when we change ice into liquid water, H2O, you have to put heat into it. So we're going to say you have to put heat into ice in order to change it to water. And then you have to put in even more heat if you want to change water into a gas. Now, let's go backwards. So if you started with a gas and you wanted to change it into a liquid, heat would be given off. So heat would come out of the system. And then if you had liquid water and you wanted to change it into ice, also heat would come out of the system. So let's go a little bit further now. And so on Jupiter, we're starting off with this hydrogen, and it's changing into a liquid. So it was a gas, and it's changing into liquid hydrogen, so it gives off heat. And then whenever the liquid hydrogen changes into this metallic hydrogen, it will also give off heat. And so that's the energy source for Jupiter and Saturn. It is not sunlight. So the energy source we think that drives the weather systems on Jupiter and Saturn and Uranus and Neptune is this internal heat that is being given off. And also another thing about the Jupiter and Saturn is that basically they don't have a solid surface unless you're considering that planet-like object very, very deep into those planets. So there isn't a surface then that's going to slow down those winds. So that the wind systems on Jupiter and Saturn and Uranus and Neptune are very, very high in comparison to the wind systems on Earth. Okay, now let's talk about storms and talk about hurricanes. So you should be familiar with what a hurricane is. You may not be so familiar where they come from. So on Earth, hurricanes begin as tropical storms off the coast of Africa, and then as they are carried across the Atlantic Ocean by the ocean currents, they pick up energy from the hot water from the tropics. And then they begin to spin because of the Coriolis effect. Because the Earth is rotating, that causes wind systems in the northern hemisphere to bend to the right, and in the southern hemisphere it causes the wind systems to bend to the left. But the net effect is, as these tropical storms are moving across the Atlantic Ocean, they're picking up energy and they're going to start to rotate. And eventually they turn into hurricanes. Now, when they hit land, though, they start to dissipate because their energy source is the ocean. And once they go over the land, they're not picking up as much energy, and so they eventually just peter out. But on Jupiter, however, it has a storm called the Great Red Spot. And I put the word hurricane in quotation marks because it really is acting like a hurricane. It is spinning, and it is roughly 3 times the diameter of the Earth. So it is a huge, huge storm. Jupiter has higher winds than what the Earth does, so that means that this hurricane is going to be stronger on Jupiter. And also, because Jupiter is spinning faster than what the Earth is, the Coriolis effect is going to be stronger. So again, this is going to be a very strong storm. Another thing about the Great Red Spot is it's in between 2 of the bands of Jupiter. And each of those bands is going to be a convection cell. So do you remember when we talked about Earth's convection cell, what was in between convection cells? It was called the jet streams. And so on Jupiter, there are high wind systems, these jet streams, that also feed the Great Red Spot. Now there are also other storms on Jupiter, but the Great Red Spot is the most famous one. Galileo actually observed it using his little telescope. And so it has been churning for at least 400 years. We don't know if it's a permanent fixture on Jupiter or if it's something that is eventually going to run out of steam, just like a hurricane on Earth does. So we don't really know that yet. Okay, we're going to take a break here, and in our next segment, we're going to talk about those bands of Jupiter.